Good afternoon. My name's Andy Ebbs. I'm a solution consultant at OpenText. I specialize in high availability and migration. And today we're going to look at Carbonite Migrate and how it can be used to migrate between different platforms. Specifically today, we're going to be looking at migrating an Azure virtual machine running Windows 2019 to an Exoscale environment, another cloud, which is running also a Windows 2019 machine that we're going to overwrite with a copy of the configuration from my source Azure machine. The slide on the screen here shows in a lot of text what I'm doing, but essentially I'll have a source machine which will be running in Azure, running Windows 2019. Could be running any other application, SQL, SAP, Oracle, could be a file server or an IIS or something like that. Doesn't really matter what the application is. And then we're going to replicate to a target machine that's in Exoscale. It's a pre-provisioned 2019 machine just from a template. I've installed our agent, small agent on the source and small agent on the target, added them to our console, and we're going to now create the job to migrate them, or migrate from source to target, Azure to Exoscale. So the first thing I'm going to do is show you the servers. So I've got some RDP sessions here. So I've got a source machine, W19 Azure source. You can see this machine's host name, and it's running as a machine at the moment. And then Exoscale, W19 Exoscale target. So this is going to be the target machine. So this machine is going to be transformed into a clone of my source machine. So on the source machine, just to show that it is running at the moment and to give us a point in time, I'm just going to create a text document on the desktop, and I'll just call it Andy. There we go. So we've got a file just to show that it's a live server. The next thing we're going to do is go to our Carbonite replication console. So if I just bring that up, you can see I've got a few machines in here already. There's the Azure source machine, the Exoscale one. I've also been doing demos, and you'll probably see those online because I'm doing a series of different demos to show anything to anything migration. So the previous one I did was Azure to Google Cloud. I'm basically doing the same process here, but this time to go from Azure to Exoscale. So I've got my Azure source machine. I've got my Exoscale target machine. I've just added them to the console, and then I can just right-click on the source machine, choose Migrate, and it will give me a couple of different wizards that I can choose from. So the first one is the file and folder one. If all I want to do is move some file shares, it's ideal. If you've got some SQL database or something, we could use that one. It's not going to do any applications or system configuration or anything, but sometimes if you want to go between different versions of Windows or from one disk to another, it's very useful. We're going to focus on full server migration, which is the one that allows you to take everything, a copy of the operating system, applications, service packs, desktop icons, everything. If we were going to a Hyper-V or an ESX environment, then we'd be able to use one of these workflows. They do a little bit more automating of the provisioning of the target end, but essentially they're using the same replication engine as the other two here. So we're going to choose the full server one. The other thing is I'm going to deselect the D drive. The D drive on an Azure virtual machine is used as a swap file. So the swap file is stored on the D drive, so there's not really any data there that we need. And I haven't provisioned a D drive on my target machine, so there's nowhere for the data to go. If I was to set it up, it would be pretty pointless anyway, so I've just left it out there, so we'll just exclude that. I then click Next and choose my target machine. So this is the Windows 19 Exoscale target machine. And then we wait for it to gather a bit of information about these servers. The other thing, maybe just quickly show you, just emphasize the environment I have here. So my Exoscale and my Azure machine. So my Azure machine is a machine based in the UK in Zone 1. It's a V2 machine, D2V version 3, and it's 2 processors and 8 gig of RAM. My target machine that I've created in my Exoscale environment is now based in Germany. I think Exoscale, I think it's a Swiss company, so we've got Germany and different regions here, but there wasn't a UK one, so I've used Deutschland, France one. But you can see the size of the machine, 4 gig of RAM, so it's got half the amount of memory. It doesn't have to have the same amount of memory. It doesn't have need to have the same number of processors. Maybe when you fail over, you could scale it up if you wanted to increase or decrease the amount of resource. But that should be sufficient for just running a plain Windows operating system and our agent at least. The next thing I'm going to do is go back to the Carbonite replication console and we'll create the job a bit further. So these are the default options. I'm not really going to change much here. There's the name of the job, some settings for the way we fail over. I want to keep the target machine's network address the IP address that was created when I created my new Exoscale machine, because it'd be easy for me to RDP into it again. If you do need to fail over the IP address, you just leave the default setting there. It's not always that useful in a cloud environment, so I'd normally retain target environment. If I was using machines that are in DNS, we've also got the option to update DNS servers to repoint the users automatically during failover. There's advanced settings for networking, for synchronization, for the path through the network for replication, some more advanced ones for what data we actually synchronize across and where it gets stored. But the only other option I'm really going to change is turn compression on. If I was on limited amounts of bandwidth, I could also set scheduled rules for different times of the day and so on for the amount of bandwidth that's available, so that you can restrict how much bandwidth our software uses for replication. But I'm just going to leave it with full bandwidth. Then I'm going to click Next, and we validate. And you can see we're getting a few checks done here, lots of nice green ticks, which show that it was happy with the settings I've given it. But it has flagged up a warning just to tell me that there's a different amount of memory on the source and target. I think I pointed that out. So we had 8 gig on the Azure source machine, but there's only 4 gig on the target machine. It's perfectly fine from a migration point of view. It just means that if you're failing over an application that needs 8 gig of RAM, you maybe need to increase the resources once you failed over. So I'm going to click Finish, and that's created the job, and it's going to start synchronizing the data. So you can see not an awful lot to configuring a protection job. Here's my job that's been created. It's just connecting, and you'll see the little logo will change here as different processes are met. Synchronizing the data. We can already see it sent some data already. So it sent about 200 mega data. After compression, you can see it's halving that data. In fact, it's almost a quarter of that data. Depends on the type of data, how effective the compression is, but it's quite effective. Now it's going to take it a few minutes to synchronize this server. I'd normally expect to synchronize what I presume is about 16, 17 gig of server over 2 servers, one in UK and one in Germany. It's probably going to take it about 10, 15 minutes to do that. So I'm going to leave that running. While it's doing that, before I just pause, just wanted to show you one more thing. If we look at the virtual machines, which are still running here, you can see the users are still live. I can still go to the file Andy here, and I could maybe change it to say Exoscale, and it's still a live server. If you look on the Exoscale machine, you can see it's got a different colored background. So my Azure machine, I've given it an Azure Blue source desktop, just to make it clear which machine I'm working with. The Exoscale one, I've just left it with the default Windows one. What you can see though is if we browse the file system, the file that I've modified on the source machine hasn't been written directly to this desktop. It's been put into a temporary area, staging folder, and I can actually browse to that staging folder, which is on the C drive, staging SSM. I can go into the file system there. I can browse through. I can see the user directory, and maybe if I went a bit slow, you can see also Windows and program files and so on. And this is a live copy of those files and folders on the source machine. Now they're currently being synchronized across, so they're not going to be fully accurate at the moment. It's taking a few more minutes. But we do prioritize new change. So because I created that Exoscale file on the desktop, that was a new change. It's been sent across and replicated already. So you can see that Exoscale one. If we went to the source machine and just maybe modified that one and got the whole file there, I'm going to do that. Sorry. I'll just take the file, just modify it, just put a number 2 on the end of it. As soon as I commit that, that's been replicated across to the target. You maybe just saw a slight lag there. There's a little bit of latency just because, we're changing something in the source machine, it gets written to disk. Our filter drivers, which is how we replicate the data in real time, they get hold of that transaction, they send it to the target machine, and then it updates the file system on the target machine. And just to reiterate, my source is in the UK, my target is in Germany, so there's going to be a few seconds or milliseconds of delay while that happens. As we go back to the replication console, you'll see it's now at about 20%. It's going to take it another 5 or 10 minutes just to synchronize that data, although it's going quite quickly. If you're working with an environment with terabytes of data, it could take a few hours or days to send that over a wide area network. We have all these tools to make sure that if the bandwidth is intermittent, it drops out every so often, or slow, we can queue changes, and when the bandwidth improves, we'll send those changes across. So it will self-heal and continue replicating even if the link goes down for 5 or 10 minutes. It just means your migration might take a little bit longer. So I'm going to leave it there. I'm just going to pause and then I'll speed up and we'll catch up once the data's in sync, which is probably going to take it a few more minutes. Okay, so it's almost finished with its replication phase or synchronization phase over 99.4%. You can see it's managed to send 15 gig after compression, about 8 gig, and it's almost at 100% there. As previously shown, the source and the target are still online, and hopefully if we switch back now, it's now protected. So basically the data is in sync between the two. The reason we use the term protected is because these are using the same piece of software as Carbonite availability. It's the same replication technology. It's originally designed for high availability. So you can use this to protect data from one server in one location to data in another, using exactly the same wizard I've shown you, but with a heartbeat to make sure that if the source machine fails, it automatically switches over to the target. So you can have a physical machine in one location, replicating to a target machine in Exoscale, and if your physical site failed or the building burnt down or something, you could spin up a replacement in Exoscale within a few minutes, which is what I'm going to show you now. So the data's in sync. I've already shown you that the source and the target are still online. So we're now going to right-click on the job, and we're going to say that we want to fail over or cut over. And when I click that button and confirm that's what I want to do, it's going to take it a few minutes now, but the first thing it's going to do is shut down the source machine, and we might be able to just catch that if I switch over to my console here. We'll see the source server. We'll get a message in a second as Windows shuts down on here. Now we shut it down so that if there's anything in memory, maybe it's running SQL or SharePoint or something, anything in RAM will get written to disk. Our filter driver will see those last few changes. It will send them over to the target so that we don't lose any data. So you can see the source machine's actually logged us out there, it's shut down, and the transformation of this machine has now begun. And that's basically the data being moved from that staging folder that I showed you here. That data is now being moved into the correct position, so we're overwriting the plain file system that was on the target machine. That's probably going to take it another 5 or 10 minutes, but this is the downtime period. Up until I press the button to fail over, the users could continue working throughout the installation, the configuration, the synchronization. We could then keep the users connected until we were ready to actually do the failover. And it's only really when I press the failover button that we have 5 10 minutes while the source machine is shut down. The target machine is transformed by moving the files from the staging directory into the correct location. We merge the registry so that we can fail over between different hardware, because the source machine was Azure with Hyper-V. We're going to be discarding all the registry entries regarding the Hyper-V virtual machine, and we're going to be keeping the KVM virtual machine settings that are used by the Exoscale environment. So let's maybe just go back to the Carbonite replication console for the time being. You see it's about 25%. As with any good percentage bar, it's going to hang on there for a few minutes, and then it will suddenly speed up and we'll get to 100%, at which point the target's going to get rebooted as well, and I'll come back in and we'll log into that machine to see the successful failover. Okay, so I moved away from my computer for a couple of minutes while I made myself a cup of coffee, and while I was doing it, it speeded up, or maybe it didn't speed up, but it completed the synchronization phase where it was doing the final conversion of the server while I wasn't recording. So unfortunately, it's come to the screen here, and it's not got an error message, but in fact, I know it's failed over successfully. It's just going to take it a little while, just while the machines are rebooting, and then it will tell me that it's failed over. We can see that now if I go to the RDP sessions that I had. I've still got the GCP target machine here. That's not what I'm using though, so I'm using the Exoscale one, which has logged me out. So there's a source to the target. If we choose that target machine and I now try and reconnect to it again, you can see it's now letting me create a session. It's got the password from the source machine, so I just need to type that in, and it should hopefully, if I've got the right password, totally different credentials, in fact, because I used Andy as my username. So these are the credentials I used on my Azure virtual machine. So I'm connecting to the Exoscale IP address, or the IP address I used from the Exoscale machine. And it's logging in, but it's got the desktop, the blue desktop that I had on my Azure source machine. It's got the file that we changed on the Azure source machine. It's asking, do I want the networking settings and so on to be discoverable. And if we look at the server, it's got a new host name, which is the Azure source hostname, because we failed that over as part of the migration. One other message that you might have just seen pop up again a second ago was just about the swap file. Because on the Azure virtual machine, it is by default on the D drive. When we fell over to the target machine, it doesn't have a D drive. It has no place for the swap file, so it's just warning us that it hasn't created one. It's just created a temporary one, and it allows me to put it somewhere else. So it's recommending that, and I can set that, and the machine will need a reboot to apply it. But I have failed over successfully. We've got the desktop, and this is now cloning my original source machine. So hopefully that made some sense. If anything I've shown you hasn't made any sense, or you got any questions, then please reach out, and I'll be happy to go into more detail. It hasn't yet come up with a thing, but if I give it a second or two, we will get a thing to tell me the failover is successful. Like just tell me here at the bottom that it's failed over as well. But it's just still trying to talk to the target machine. I'm still using the old IP address, I think. So if you do have any questions, please reach out. My email address is aabs@opentext.com. And if you want to see any similar configurations, I'll probably do a similar demo for Linux, but I've been doing the same sort of demonstration for Google Cloud Platform, for Azure, for Proxmox, for ESX, and I'll continue making a few similar videos just to show how we can be used, or Carbonite Migrate can be used to migrate anything to anything. So whether you're going from physical to cloud, cloud to virtual, virtual to physical, you can use the workflow I've shown you today. This is an example of Azure to Exoscale. So thank you very much for watching, and give me a shout if you need something. Thank you. Bye-bye.